Okay, so this is the video for significant figures. And significant figures, they go everywhere. We use them all the time in science. Not as common in math. That's more in like, way in the future kind of stuff. But in science, it's really important because significant figures tell you what digits can be trusted. Kind of goes back into like precision and uncertainty, which we will also talk about, not in this video, but in a different one. And so for example, if you use if you get, I don't know, again, I'm just making numbers up right now, say theoretically, like I don't fucking know, 1.5 times 2.53, both of those have 3 sig figs, but then when you multiply them together, say you get a number with crazy number of decimals. It doesn't make sense that you had 2 numbers with only 3 digits make a number with a crap ton of digits. In some cases in infinite digits. So you essentially round that to what parts of the digit, what parts of the number are certain, which is the sig figs. That's where they come in. This interacts with precision and uncertainty a little different, but essentially the same. But in this case, we're just going to talk about the very basic rules. Okay, so the general sig fig rules: any non-zero digits are always significant. So if you're looking at a number and you see anything that is not 0, that for sure is a sig fig. Unless there's like something within the precision or uncertainty that tells you it's not, But as I said, in this case, we are not considering that. Okay, the second one, any 0 contained between like 2 non-zero numbers is significant. Say if you have like 202, you might think the 0 is not significant, right? But because it is trapped between these 2 zeros, it becomes significant. Or I mean the 2 2s, not 2 zeros. There we go. Okay. And then we have the third one. Leading zeros are never significant. So for example, if you had, I don't know, 500 and someone puts like, I don't know, 2 zeros in front of 500 for some fucking reason, these are not significant. Even though there's like a decimal, these are, actually, you know what, fucking ignore that. These are not significant. And we'll go into why I crossed that out a little later, but that's more of an exception thing. Let's see. Come on. There's got to be an easier way for me to erase this stuff. If I ever figure out to edit, I'll fix that. Okay. Any 0 contained, oh, wait, no. We're on number 4. Okay, so final or trailing zeros are significant only after a decimal point. So, that can be pretty important. And we're going to go into that in our example problems. But if you have 500, these zeros are not significant until you put a decimal here. Then they become significant. And that's what this is talking about. Okay. And then you have kind of like specific sig fig rules when it comes to equations, like when you're solving stuff. So I'm going to go with the multiplying and dividing first because it's simpler. Multiplying and dividing is pretty simple. It's based on the number with the least amount of sig figs. So if you're multiplying 2 numbers, one of them has 3 sig figs and one of them has 2, the one with 2, you're going to go with that number. So that's how many sig figs you have. Whereas like with adding and subtracting, the sig figs are based on what number has the least amount of decimals. And this has to do with precision. I'm going to keep inserting that there to, increase the thought process, but we're not going to go over it. Okay. But we're just going to deal with the fact that it's going to be mentioned. But an important thing about the fact that the sig figs are based on the number with the least decimals is that the number of decimals is not the number of sig figs. So for essentially the entire first quarter of chemistry, that's what I thought. I thought when they said sig figs are based on the number of the least decimals, I figured, oh, the number of decimals is the number of sig figs, right? That's how everything had worded it before, but it needed to be more specific. So the number of sig figs does not equal the number of decimals. All the thing tells you about the number with the least decimals is which number you're going to use to tell your sig figs. That's completely separate from the decimals though. And we'll go over that in our example problems, okay? And then a quick note, when you're solving calculations, in chemistry, you'll always have sig figs. It'll be different in math though, of course. But when solving those calculations, do not round to sig figs while you're solving. You want to wait until the very end. So I've gotten in the habit of, doing my sig figs like that with like a circle, because in your equations, you don't, at least currently, I don't know about the future, but at least currently I don't have any circles in my equations. So for me, that's an easy way to keep track of, the sig figs before I can apply them. You only want to apply the sig figs to your final answer. But what's also good to know is that with your final answer, say you did a bunch of math and you ended up with two numbers you needed to add together. You don't just go, like the total sig figs are not just based on the sig figs of those two numbers being added together to get your final answer. The sig figs are changed and adjusted throughout your entire equation, and you need to keep track of how they change, because it's the entire equation that dictates the sig figs of the final answer, not just the last equation or the last addition problem that finally gave you your answer. Hopefully that makes sense. Okay, so now on to our example problems. So per usual, I'm going to use a physical calculator. So in this case, you'll see here we have 1.13 plus 2.2. And then we'll do this math without the sig figs first, so we know what it equals. So you have the 1.13 plus 2.2 equals 3.33. Okay? But what you got to do here is you got to go back. Usually, just to add, you want to keep track of the sig figs before you solve. But I'm just doing it like this, so we have it all here at once. So what you'll see here is you have this 1.13, that's 3 sig figs. 2.2 is 2 sig figs. We go back to the addition rules. Sig figs are based on the number of the least decimals. So this works out because, it works out both ways. Where with the adding, this number right here has the least amount of decimals, the 2.2. It also has the least number of sig figs. So that works too. It doesn't matter at all, but it is it's nice, makes it nice and easy. But say, for example, this number was 12.2. It had 3 sig figs, just like this one. You would go with this one because it has the least number of decimals. Now let's go back, get rid of that. We'll have to fix that. Okay, 2.2. So we have the 3 and the 2, and we know because of the, the addition rules, that means that this is also going to have 2 sig figs. So you gotta format that correctly. So you have 3.3. The 3 doesn't change this 3. So all you're left with is 3.3. That's your answer to 2 sig figs. There you go. Now we have this one. We have 2.3 times 2.456. And this time we'll do it how you're kind of supposed to do it. So we're multiplying here. Because of that, we know that it's just based on which number has the least number of sig figs overall. So this number has 2. This number has 4. So we know that this one right here, that's what we're going to go with. So when we multiply these together, the 2.3 times 2.456, that equals 5.6488. But remember, we want 2 sig figs. So we want this and this, these two. We look at here, the 4 4 is less than 5, it doesn't change the 6 at all. So we're left with 5.6. That's the answer, 2 sig figs. And now here's where we go into some of the interesting stuff I tried to mention earlier, but cut myself off. This is where, critical thinking comes in mind. So you have this 100 here, has no decimal point though. That means that these zeros are not significant. So in this case where you have the 100, there's only 1 sig fig there. That's it. And so if you're solving and you have this 100 in your equation without a decimal at the end, that means it only counts for 1 sig fig. Now, we have the case of 100 with a decimal in the end. That all of a sudden makes the zero significant. So now this has 3 sig figs. Now with the 91, it'll work a little different. Because here you have 91 with no decimal. So this is very interesting. Until like a little while ago, I had just assumed, or at least from what I had learned, from what I understood, I thought this meant that none of it was significant, that it doesn't play into the problem at all. So similar to how you have like exact numbers, like where you have the gas constant, a number that the sig figs there don't play into your equation at all. But this does. It's not one of those exact numbers. It's just 91. So in this case, both of these have 2 sig figs. And that's what really tripped me up before, because as I said, I figured, I think what happened is I only paid attention to what happened to the 100 with the decimal. And that's why I just thought, it's even worse than that. When I looked at the 100, I thought this was 0 sig figs, not even 1. I thought it was just 0, which is, it's just wrong. And so it's important to make sure that you keep that kind of stuff in mind, because if you have some, some beliefs in your mind of how to solve something and it's actually incorrect, that can really mess you up. And when it's something like this where it seems so minuscule to the problem, when you're solving something really complicated, you might think that was something wrong with the complicated, stuff, when really it could be something as simple as just the number of sig figs you rounded to. That's why you got the answer wrong, So that's a good thing to keep in mind. I probably should have put that as the first one, but the fact that it's covered it all is that's good enough for me, So with this example problem, we're going to kind of go into complex equations, because things can be a little different. I'm going to give myself some more space here. So let's rewrite this. So you have 250 plus 42.01, and then 7.50 on the bottom. So an important thing to identify is that we have 2 different rules here that are going to apply, because you have the addition on the top, and then you have the division. So because of PEMDAS, I don't even have to write it down. We'll be solving the top part first. But just like, usual, you got to keep track of the sig figs. So in this case, we're doing addition. So it's the number with the least sig figs that is going to, not sig figs, the least decimals that is going to be our indicator. So in this case, that's going to be the 250. This is where the rule we just went over comes in. There is no decimal at the end of this 250. So this is not 3 sig figs, it is 2 sig figs. Now with this 42.01, remember this 0 is being trapped between 2 numbers, so it is significant. So this one has 4. Now we already know which one we're going to be going with, which is the 250, no decimal. So it's going to have 2 sig figs. So when we solve the top portion, again, using my trusty calculator, we get, I'm just going to write the number up here. How do I want to write this? Let me think here. Here, I'm gonna round it to sig figs and then write the original number in parentheses. That works. So I have 2 sig figs. Oh, actually, never mind. I figured out how I want to do this. Okay, so the number we get when we add these two together is 292.01 over that 750. So remember, we were told to round as 2 sig figs. So you can use scientific notation here to, format this 292.01 to 2 sig figs by moving that decimal. But you haven't finished the equation yet. And so an important thing that we went over earlier that you've got to remember when solving is that you don't apply your sig figs while you're solving. You don't do this. You're not going to round the 2 sig figs here because this is not your final answer. All you do is keep track of it. And now this goes on to the 750. That has 3 sig figs. That 0 is a trailing 0 that comes after the decimal. And remember, the trailing 0, as long as there's essentially even if it was that, trailing 0 would become significant. That's just another rule. Okay. There we go. So this is 3 sig figs. And we put that here. And so remember, now we're doing division. And so in this case, we go with the number with the least sig figs, which is this one. Our final answer is going to have 2 sig figs. And now here's where it's important that you keep track of them. Because if you didn't keep track of your sig figs here, you might be inclined to think that this right here has 5 sig figs, but it doesn't. It's just written that way because, again, it's not the final answer. So that's important. Again, I'm just reiterating how important that is. So now we have the 292.01 divided by 750. So we get this kind of crazy number, 38.9346, keeps going. It's one of those numbers that just keeps going. On your calculator, it'll round the last digit, even though the number just keeps going. That 6 goes on forever. In fact, you could put the little repeating symbol saying that that's going to keep repeating. But aside from when I learned that in middle school, people don't really use that. So that's more just a note for me. So now we have 2 sig figs. So we want to apply that. So in this case, we're going to round here because of the 9. And so our answer is going to be 39. There you go. So that's how that works. And so that's how all that stuff factors together. And especially when you get into more complicated, equations, you really got to keep track of that stuff. And, as I said, just remember, you don't want to round to sig figs until the end. There might be times where a professor wants you to write your equation as if it was like a final equation. You'd still do all the math yourself without rounding to sig figs at all, but maybe they wanted you to write the equation with all the components being in proper sig figs. That's rare. They don't usually do that. But you do want to keep that in mind. Just because they say write it out this way for me so it looks pretty doesn't mean they want you to solve it that way, because that would be incorrect. Let's do a little thought experiment here. Let's not pay attention to sig figs at all. So let's start again. And I'll erase all this, this fact. So we're going to ignore sig figs here. I'm going to go 250 plus 42.01. You get this number. And I'll just say sometimes I put stuff in my calculator that I know the answer to. I'll do 4 times 2. Because sometimes my brain doesn't work, where I'll be like, 4 times 2, yeah, that's 16. And I will not see anything wrong with that. It will not, there will be no part of me that's like, that's incorrect. Unless someone else points it out. And so that has gotten me in a lot of trouble throughout my years, where I've written down the wrong number. So I just put everything in my calculator. It just makes sure that everything is correct, right? Okay, so in this case, we're gonna go back to what we're doing. We're gonna divide again. We're gonna get that crazy number again. So we're gonna rewrite it, with that repeating 6. Okay, so in this case, we're not gonna do what we're supposed to. So we're just gonna go with this. So, with the rules for dividing, so one of the, the least number of sig figs. So in this case, we have 3. And because we didn't pay attention to anything here, because we're dumb when we solve this problem, then we think it was 5. So we go, oh yeah, totally. The sig figs, that means you need 3 sig figs, totally. So you write down this. And then, you put it into Alex and you press enter and it tells you, oh, this is wrong. You're like, oh man, there must be something wrong about what I understand about the math. Maybe I did the formula wrong. And you go on this whole path of trying to figure out what the complicated stuff you did was wrong. And it's just this simple mistake. Now, luckily, Alex is pretty good about giving you a little reminder before you, press enter, where it'll be like, hey, did you double check your sig figs? Which is great, But on a test, on a quiz, everywhere else that isn't Alex, they're not going to give you that warning, that extra shot to get it right. If that's just going to be what it is. A professor will see this on a test and mark you wrong for it because it's an improper sig figs. Unless they explicitly stated that they wanted it in 3 sig figs, that's different. But if you're just going by the math, that this would be wrong. And so that kind of shows you just why this is all so important, the keeping track. And maybe in the future, you'll come up with a different way of keeping track of the sig figs. For now, this works pretty great. Just doing little circles. Yeah. And, with the memory loss, it sucks a little bit because every time I do these problems, I have to remind myself between the adding and the different versions here, which rule do I use? Because I get it mixed up sometimes. So there's no harm, no shame in double checking the rules and making sure you did it right. And that, that's why these videos exist, is to, if something ever gets dumped out of your brain for, any reason, then that way you have or me, I guess, has an easy way of, going back and checking this stuff. Okay, so yeah, I guess a little quick recap. We've got non-zero digits are always significant. That's any number that is not 0. Any 0 contained between 2 non-zero numbers is significant. They're giving it a hug. They're making it significant. Leading zeros are never significant. And that same with the final or trailing zeros are significant only after decimal point. But remember this also applies when you have like 500 and you put a decimal. Those zeros become significant. So it could also be the zeros before, but this is just how it was written. So that's how it is. Adding and subtracting, use the sig figs for the number with the least decimals, but the sig figs are based on the number itself, not the number of decimals. Freaking God. And then multiplying and dividing based on number with the least sig figs. Just remember, as we just went over, when you're doing your calculations, do not round to sig figs till the end and keep track of them. Keep track of how they change. Okay, that's it for significant figures.